Today we will discuss the problem related to chapter 28. Problem number 5. Find the equivalent resistance between point A and B in figure 828.5. A potential difference is given 34 volt between the point A and B. Calculate the current in each resistance. So, as according to this figure, the voltage that will be provided between these 2 points, that will be a 34 volt. The voltage is this, and as so the current I will be passing through this all the circuit, and the same I will be passed through I, and also this I will be passed through, and this I will be divided into two part. That is because according to Kirchhoff first law, first law, this current will be divided into this I will be divided, but for complete resistance, for this complete resistance, the current will be I. Okay, so so total what first part is what will be the A part is what will be the equivalent resistance between A and B, mean what is the equivalent resistance of the circuit. As we know, the total resistance will be sum of that will be R1, and this, if I represent this resistance, if I represent the complete resistance by if I represent this by RP, okay, then this will become R1 plus RP and plus RP mean parallel resistance, and or if I say this is R1, this is R2, and the center, that is RP. So RP is actually parallel resistance, and we know that the parallel resistance, so if we put the value, so this will be a resistance R1 plus, what will be the parallel resistance for parallel resistance? This will be or if I say that above is 1 by RA, and this is formula of the parallel resistance, as I have already discussed in the class, that is -1 plus R2. Okay, R1 is given 4 plus RA is 1 by 7, RA is 7, and RB is will be 1 over 10, and -1 plus R2 is 9. So according to, when we add it with the help of calculator, this will be become a 4 plus this parallel resistance will be uh, 4.112 plus, that is 9, sorry, that will be a plus 9. Okay, so the result will be equal to, yes, the result will be become according to calculator. When we use using calculator, that will be 17 point. Calculator is giving the result 17.15. So this will be the equivalent resistance for this complete circuit. Okay, so as we, and for B part, the B is find the potential difference applied between a, calculate the current in each resistance. So we have to find the, firstly I have to find the current passing through the 4 ampere. To find the current 4 ampere, I have to consider that delta I is passing through R1, R2, and this RP2. Okay. This I current will be passed through R1, this resistance R2, and the combination of this RP. Okay. So firstly, we have to find this. So let's find this B. So B delta V equal to, as we know that according to formula, delta V is given. Delta V is equal to IR. Okay. R we have find it. R this we'll put this value here. So uh, delta V is also given. Delta V, this delta, this is also given. So the uh, so we have so this implies that so I is as I have so this implies that I equal to delta V over R, and this will be delta V is equal to 34, and R is complete, the R of complete circuit is 17.15. So result will be, after calculating, the result will be equal to this is 1.99 ampere. Okay. Sorry. Yes, ampere. This will be current will be this. So this will be I, and this I that I will be 1.99 ampere. Yes, will be passed through, will be for, yes, this will be for R1, R1, this will be for R1, RP, the combine, and R2. So this will be for this 4 ampere, for this R1 4 ampere 4 ohm resistance for 9, and the combination 4.12. This the I will be 1.9 and for 4 ohm, this, and for 9. Okay. So this is the current we have find the current passing through. So I we have find the I of so we have find it this I for R1 and R. Now for now uh, now we have to calculate I for now we have to calculate I for RA and RB. So how we find RA for and RB? We know that firstly we have to find the delta V around we have not too much choices to select. Now we have to find the delta V around these 2 points. Okay. So now we have to delta V. Now we have to find 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 delta VP for RP, okay, for parallel. So how we will find delta V, delta V for delta VP, since the same current I is passing. mm, since the same I current I current is passing through or P, since the same current I is passing through I is passing through RP. So we have to find VP for RP, since same current is uh, so delta delta VP will be equal to I R P. IRP is 4.12. So we have already calculated the I. So this delta VP, firstly we have to find the delta VP, that is not given, and but I is given. I is one, this is I, and RP, this blue is RP. So 1.99 multiply by RP is multiply. So current is, as we know that current is 1.99 multiply by 4.12. So this current will be equal to, after calculating, that will be 8.18. So this will be your delta P. Okay, but we have to find the IA, and we know that, but this I will be divided between this I, so this I will be divided, which is passing through this RP, mean combination of these resistance will be divided into IA and IP. So now we have to calculate the IA and IP. For this purpose, we know that uh, uh, as we know from the formula, delta VP equal to, also equal to the IA. This is P, not B. Okay. Okay. I'm- okay. This is so our so V IA and RA, and this will be IP and RB. Okay, so IA will be equal to delta VP over RA, and delta vp we have 8.18. Ra is what is the ra? Ra is 7. Okay, so this 7 and this will be, or a will be equal to 1.17. Similarly, ib will be equal to delta vp over rb, and this will be equal to the voltage is same because voltage is parallel voltage, and rb is I think 10. Yes, 10. So then that will be equal to 8 0 point first ampere, and this will be a 0.818 ampere. Okay, so these will be required result. A, B, and this C. This will be current passing through the resistance, or I will be current passing through R1, R2, and IA is this 1.7 will be passed through 7 ohm, and IB 0.818 will be passing through the second resist, that is 10. And for complete, you may see this. I think now it's clear. For next lecture, we will meet again. Okay, so goodbye. Control.